Then the continuation of my integer and frequency synthesizer. That is the working principle. Working principle is that first we are going to the concept of five main blocks. That is reference oscillator, phase detector, low pass filter, voltage control oscillator, and a frequency divider. So the reference oscillator, that is reference oscillator produces a stable frequency such as reference oscillator produces a stable frequency such as, for example, 10 megahertz. The phase detector compares the reference signal with the divided VCO signal. VCO is nothing but voltage control oscillator. Okay, and it generates a error signal based on the phase difference of both the what reference oscillator and phase detector. Okay, this error signal is filtered and applied to the VCO as a control voltage. This VCO will adjust its output frequency until the divided feedback signal matches the reference signal. Okay, at this point only the PLL is said to be locked. PLL is nothing but phase lock loop, right? So output frequency will be given by the equation, that is F out equal to F out equal to, that is FCO, that is equal to N into F reference. F reference is a reference frequency and N is a integer. Then we are going to see about the characteristics. Characteristic is that is how the frequency is. Previously, we are going to see about that. We are seeing about that is F out equal to N into F reference. And the high spectral purity, that is a clean signal with a low phase noise. And these are the characteristics. You have to refer this. And let us see the application. Applications that where we are going to use this. That is the radio transceiver and clock generation in the microprocessor. Microprocessor also we are using an integer and frequency synthesizers. Okay, and in a radio receiver that is used in mobile phones, walkie-talkies, Wi-Fi routers, and Bluetooth devices in order to generate a carrier frequencies for transmitting and receiving the signal. Okay, clock generation microprocessor is that is used to generate a high-speed clock signal from a low-frequency crystal oscillator. It is to ensure that synchronized operation of CPU and CPU1, that is a central processing unit and digital circuits. Okay. And in communication system, the communication system, it is widely employed in satellite communication, radar systems, cellular networks, and wireless communication equipment. That is in order to provide a stable and tunable frequencies. And last one is signal generator. Signal generator that is used in lab test instruments and RF generators in order to produce a precise frequency for testing, measurement, and calibration purpose. These are the applications of integer and frequency synthesizers. Okay. Then we are going to see about direct digital frequency synthesizer. Direct digital frequency synthesizer is a DDFS or DDS. DDFS is a direct digital frequency synthesizer. It is also known as DDS. DDS is the direct digital synthesis. Direct digital synthesis. It's a technique that's used to generate precise and programmable frequencies using digital circuits and reference clock. Okay? Unlike PLL, that is a phase lock loop based synthesizer, that is integer based synthesizer, is an integer end frequency synthesizer is a PLL based synthesizer. Unlike PLL based synthesizer, DDFS, that is a direct digital frequency synthesizer, creates the frequencies directly in the form of digital. Okay, it will offering very fine frequency resolution and extremely very fast switching between the frequencies. Okay, the main component of DDS or a reference clock, phase accumulator, phase 2 amplitude lookup table, and a DAC converter. The phase accumulator will generate a digital phase values based on the frequency control. But these phase values are converted into corresponding amplitude that is these signals, that is a phase value, digitally phase values will be converted into amplitude values using a lookup table. There will be some lookup table typically containing a sine wave sounds. Okay, then DAC, what is the use of DAC? That is a direct digital to analog converter. It will convert the digital data into the analog form and it will produce a desired output signal. Okay. Then major advantage of DDFS are the high frequency resolution, high rapid frequency hopping, and programmable output frequency. Because of these features, it is widely used in modern communication system, signal generators, radar system, and SDR. SDR, in the fourth unit itself, we have learned about SDR. SDR is a software defined radio. Okay. For example, in a radar system, that is DDFS, can quickly switch between the frequency while maintaining the phase continuity. It enables accurate target detection and tracking. Okay. That is DDFS or DDS, direct digital synthesizer. It will provide a flexible, accurate, and efficient method for digital frequency generation in modern electronic system. Then phase accumulator. First, the operation of a DDFS begins with the phase accumulator. That is, it will consist of a certain blocks that begins with a phase accumulator, which adds a fixed phase increment value that is known as a frequency control word during every clock cycle. This phase increment determines the output frequency of the synthesizer. Okay, that generated digital phase values are sent to the phase to amplitude converter. First one is phase accumulator, and next one is phase to amplitude converter. That is, what is the use of phase to amplitude converter is that it will convert each phase value into the corresponding amplitude value of a sine wave using a lookup table. There will be some lookup table, right? So this digital value will be this digital amplitude value will be given to the DAC. DAC is the digital to analog converter. It converts into analog form, and that output will contain some unwanted high frequency signal. So that will be passes to the low pass filter. Low pass filter remove those unwanted components and produce a smooth analog signal at the desired frequency. This architecture enables DDFS to generate high accurate frequency with excellent resolution and fast switching speed and continuous phase characteristics, which is very suitable for communication system, radar system, and signal generator. Let us see the advantages. First, fine frequency. That is a fine frequency resolution. Fine frequency resolution, fast frequency. I have already told that fast switching speed is there, and excellent phase noise performance because we are using a low pass filter here, so the noises will be removed. So then stable and repeatable signals. And the limitations that spurious signal, that is a spurs due to the quantization. There will be some lookup table, the amplitude, that is the phase accumulator. From the phase accumulator, we are going to give the signals to the phase to amplitude converter. There will be the quantization level in the phase to amplitude level converter. And DAC, that is a digital to analog converter, that is a non that will give a non-linearity. So clock jitter can degrade the output quality. So DAC speed, that is a digital to analog converter, and resolution can limit the output frequency. These are the Despite these limitations, DDS remains very effective technique because of its flexibility, accuracy, and rapid frequency control capability. Let us see the application. Where it is used means it is used in the RF signal generation, FG, that is in the lab itself. We are using inside the FG. These blocks will be there. Okay, function generators, communication system, test measurement equipment, and software defined radios. Software defined radios for flexible digital. It is mainly used for flexible digital processing. Okay. Then direct digital synthesizer are widely used in modern electronic system because it will generate a high accurate and programmable frequency. The main applications is that it is mainly used in RF signal generation for wireless communication, function generators, and communication system, requiring the very fast frequency switching test and measurement equipment for accurate signal creation and software defined radios. Okay. Next. Next is high frequency oscillator configuration. High frequency oscillators are essential in RF and microwave communication system. These oscillators, that is, they will generate high frequency oscillators are essential in RF, microwave, and communication system. They will generate a stable sinusoidal or square wave signals in megahertz and gigahertz range and serves as a signal sources in transmitters, receiver, radar system, and satellite communications and wireless network. The primary function of high frequency oscillator is that in order to produce a continuous waveform with precise and stable frequency. So several parameters will be considered here. So several parameters determine the performance of high frequency oscillator. So the frequency stability, that is what is mean the frequency stability, that is it refers to the ability of a oscillator, that is ability of an oscillator in order to maintain a constant frequency over a time. Okay, that is a frequency stability. And phase noise. Phase noise represents short-term frequency fluctuation around a carrier frequency. It will directly affect the signal quality. So that is a phase noise. And output power. Output power indicates strength of the generated signal available to drive the uh, subsequent stages. That is heat stages. And tuning range. Tuning range is nothing but that is a range of frequency over which oscillator can be adjusted or controlled. Okay. Due to their high stability and accuracy, that is high frequency oscillators are widely used in RF transceivers and communication systems, signal generators, and data equipment. Okay. Next, we are going to see about the Colpitts oscillator. The Colpitts oscillator is widely used LC oscillator. That is, it consists of inductor and capacitor. So it's used in RF and high frequency application. So what is that? It will generate a stable sinusoidal signals, and it is commonly used in radio transmitter, receiver, and signal generator. Okay. This oscillator, that is, it uses a tapped. I have already told that this oscillator uses a tapped capacitor network. That is, it is formed by two capacitors that is connected in series. Okay, two capacitors that will be connected in series in order to provide a feedback that is required for the certain oscillation. Okay, the circuit consists of both from the Colpitts oscillator. We have to remember that the Colpitts oscillator consists of LC. That is widely used as LC oscillator. LC oscillator is nothing but it consists of both the inductor and capacitor. That will be the two capacitor we'll be using. So like a circuit consisting of inductor and two capacitors and amplifying devices such as a transistor or op-amp, that is operational amplifier. The capacitor acts as a voltage divider and feed a portion of output signal that is back to the input in phase. That is, there will be the two types of feedback. What is that? First one is positive feedback and negative feedback. Positive feedback is that is output signal will be fed to the input signal. That is in phase with the input signal, right? So negative feedback that is out of phase with the input signal. That is okay. The capacitor that will be acting as a voltage divider that will giving us a portion of output signal back to the input that is in phase with the input signal. Okay. Both the capacitor and inductor together form a resonant tank circuit. That is a resonant tank circuit, and that will determine the oscillation frequency. Okay. Let us see the main advantages of Colpitts oscillator. Yes, frequency stability is very good, and circuit design is very simple, and it will the excellent performance at a high frequency. When it is at a high frequency, the system will be the oscillator will perform better. Okay. Because of these features, it will be widely used in RF circuits, wireless communication system, etc. Then this is the formula F equal to 1 divided by 2 pi into root of L into C. That is, L is the inductor value and the C inductance and C equivalent is the equivalent capacitors of the two capacitors that will be connected in the series. What is the formula for capacitor if it is connected in series? That is C1, C2 divided by C1 plus C2. Right? So that is given there. And next is Hartley oscillator. Hartley oscillator is a popular LC oscillator that is used for generating a sinusoidal signal in RF and communication system. It is widely used for lower RF frequencies. It can be adapted for the high frequency application. Okay, it is the circuit will be the design will be very simple, and this circuit consisting of capacitor and a tapped inductor of two inductor. They Colpitts oscillator. They two capacitors that will be connected in series and one inductor will be there, right? So in Hartley oscillator, two inductor will be there that will be connected in series and one capacitor is there. Okay, you have to remember it. The feedback, that is the feedback required for the oscillation is happening from a inductor, which will be acting as a the capacitor will be acting as a inductor. Sorry, that the capacitor will be acting as a voltage divider. Here, the inductor will be acting as a voltage divider. Okay, the amplifying device will be there. The amplifying device such as a transistor or FET that will provide a gain or circuit losses. Okay. And the frequency of oscillations will be determined by the by using the formula, that is 1 divided by 2 pi into root of L into C. That is L is the total inductance in the tank circuit and C is the capacitance. Okay. You have to remember this. And for mutual inductance, that is LT equal to L1 plus L2 plus 2M. 2M is the mutual inductance and L1, L2, that is the two inductors that is connected in the series. You have to remember this. And next one is clamp oscillator. The clamp oscillator, that is, it is a modified version of Colpitt's oscillator. Okay, it provides a improved frequency stability and accuracy. It is widely used in RF communication system, but the stable frequency sources required. Okay, the main difference is that between clamps and Colpitt's oscillator is a addition of extra capacitor that is connected in series with the inductor in the resonance circuit. Addition of extra capacitor that will be connected in series with the inductor. That is the main difference. Okay. The additional capacitor, what is the use of additional capacitor? It will reduce the effect of transistor parameter and stay capacitance. Uh, that will leads to minimize the frequency drift and improving the stability. Okay. This is the main difference. And the frequency will be calculated by using the formula F 1 divided by 2 pi into root of L into C equivalent. C equivalent is the equivalent capacitance and L is the inductance. Okay. That is, and next is crystal oscillator. Crystal oscillator are quartz crystal. Okay. First, that is crystal oscillator is one of the most accurate and stable oscillator that is used in the electronic system, right? So it from the name itself um, we can get an idea that it utilizes the piezoelectric property of quartz crystal. That crystal is used to generate a precise oscillation. Okay, due to the excellent frequency stability that is widely used in clocks, microcontrollers, and microprocessor. That is, in a crystal oscillator, the quartz crystal is placed in the feedback loop of an amplifier. Okay, often using the Colpitt's oscillator. Whenever the voltage is applied, the crystal will be vibrate. Okay, then vibrates at the resonant frequency. Then due to that vibration, it will produce an oscillation, right? So the operating frequency is fixed, and it is determined by the physical dimension and thickness of the crystal. So that is generally the crystal oscillator will be operate in the frequencies of that is few kilohertz to more than 100 megahertz. The main advantage is that it will provide a very accuracy. Frequency accuracy is very high, so very low noise phase and high frequency stability, low temperature drift, and reliable long-term operation. So because of this characteristics, the crystal operators are widely used in microprocessor timing circuits, wireless communication system. And let us see the difference. Okay, difference of the four oscillator. That is a Colpitt's or Hartley, clamp, and crystal oscillator. Okay, and for that, the real-time example is that FM radio transmitter, AM radio receiver, signal generator, and quartz crystal. Okay, these are the real-time example and its application related to that oscillator. Kindly refer this. Thank you.